So, welcome students for the chemistry lecture. And last time you have learned the ferric chloride water system, and you have also studied the different euditic points in the ferric chloride water system, and also you have learned the congruent melting points in the ferric chloride water system. And all of you know the four hydrates they are formed, and these are dodecahydrate, heptahydrate, pentahydrate and tetrahydrate. And due to addition of ferric chloride into water, the freezing point it decreases along the curve AC reaches to the minimum, and this point having temperature minus 55 degrees centigrade, it is the cryohydric temperature, or it is also called as eudatic temperature. And this point it is with non-variant system, as at this point three phases are in equilibrium: ice, dodecahydrate and solution. Similarly, the point D, F and H, they are also the non-variant systems. And in this diagram, the point C, E, G and J, they are the congruent melting points of dodecahydrate, heptahydrate, pentahydrate and tetrahydrate respectively. You have learned this phase diagram. Then today you are going to learn here the three component solid liquid system. And all of you know three component system, that means the composition of all phases that are involved in the system, they are explained with the help of three components. Okay, then we know that the Gibbs phase rule, we have F it is equal to C minus P plus 2, and if the value of C, that means component, it is equal to 3, then the Gibbs phase rule becomes as F it is equal to 3 minus P plus 2, that is F it is equal to 5 minus P. And this equation signifies that to find the degree of freedom F of the three component system, we have to subtract the number of phases from 5 to obtain the degree of freedom. And when the number of phases are 1, then the degree of freedom becomes 4. Okay, that means 5 minus 1, we have F it is equal to 4. If we consider minimum number of phases equal to 1, then we have F it is equal to 4. That means 4 degrees of freedom, pressure, temperature and composition of two components will be required to explain the three component system. And graphical representation with four variables is not possible, so that the two variables, that means pressure and temperature, are kept constant. Hence the reduced phase rule for three component system becomes here 3 minus P at a constant temperature and pressure. Here from this 5 we kept constant the two variables, and that two variables are pressure and temperature. So the reduced phase rule for three component system, it becomes as F it is equal to 3 minus P, and when the number of phases it is equal to 1, the degree of freedom it becomes equal to 2. When number of phases it becomes equal to 2, then degree of freedom it is equal to 1. And when three phases are there, the degree of freedom it will be 0. That means non-variant system. And by application of this reduced phase rule, F it is equal to 3 minus P, we can calculate the degree of freedom. Then here the three component systems phase diagram, it is the uh, triangular graph. With the help of triangular graph, we can explain the phase diagram of the three component system. And the scientists Stokes and Roosboom, they have expressed the compositions of three components with the help of equilateral triangle. And all of you know the equilateral triangle. And certain rules are there to study the phase diagram. The first rule is each of the corner or apex of a triangle represent 100% weight of one component. Each corner it represents the 100% weight of the components, that means A, B and C. As a result, the same apex will represent 0% of the other two components. Then the area within the triangle represents all possible combinations. That means the area within the triangle it represents the compositions of all the three components. Then combinations of A, B and C to give three component system. This is the second rule. Then third rule, if a line is drawn through any apex to a point on opposite side, then all systems are represented by points on each line have a constant ratio of two components. And any line drawn parallel to one side of the triangle represents the ternary system in which the proportion of the component it is expressed. Here these are the uh, four rules by means of which you can study the phase diagram of a three component system. Remember that the scientists Stokes and Roosboom, they represented a triangle, equilateral triangle as a phase diagram of the three component system, and the apex of a triangle it represents the 100% composition of the three components, and the lines which are drawn parallel to the three sides they express the composition of any two components, and the area within the triangle it represents the compositions of all the three components. This is the explanation how we can express the composition of all three components with the help of equilateral triangle. So this is the phase diagram of three component system, and the three components here we have water, and this is here it is the water, 100% water we have here. Then here the chloroform CHCl3, and here we have acetic acid. This is the phase diagram of water, chloroform and acetic acid. Here at this apex we have acetic acid. Here acetic acid it is shown. That means the composition of acetic acid here it is 100%, or here there is a 0% H2O and 0% chloroform. Similarly, at this apex, at this apex there is 100% water. Similarly, here there is a 100% chloroform. Okay, then Here these are the lines drawn parallel to every side, and here these are the lines parallel, and each side it is divided into 10 equal parts or 100 equal parts. Each side of the triangle it is divided into 100 equal parts or 10 equal parts, so that we can express the composition of all the three components in the system. And remember that here any side, that means this side, it explains the composition of two components, and that two components are here H2O and acetic acid. This side here the composition of H2O and CHCl3 is expressed. Similarly, this side it expresses the composition of CH3, COH and chloroform. Remember well. And within this area, we can explain here the composition of all three components. Okay, the composition of all three components. Any side it expresses the composition of two components, and inside the area we can express the composition of uh, any three components. Suppose we have, this is the point inside the area, and at this point we can have the composition of here acetic acid, the composition of chloroform, and similarly the composition of water also. Remember, suppose this is our P point, and at this P point we can have the composition of acetic acid 0.4%, the composition of here CHCl3 it is 0.6%, and the composition of H2O here it is. Okay, this is the phase diagram of the three component system. Simply remember here the three component system, they are well explained with the help of equilateral triangle, and apex of the triangle it indicates the 100% composition of all three components. Each side it is divided into either 10 parts or 100 equal parts to express the composition, and any side it expresses the composition of two components only, and inside the triangle we can explain the composition of all the three components here. This is the in general phase diagram of three component system. Here we have A component 100%, here we have B component 100%, and here we have C component 100%. And here we can express the composition of A component. Here we can express the composition of A component, while A is 0 here, also B is 0 here. Similarly, at this point the composition of C is a 0 as well as composition of B is a 0. At this point we have 100% composition of B and the 0% composition of C as well as A. And similarly here we have 100% composition of C, okay, and 0% A and 0% B. And here this equilateral triangle it is divided into 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 10 equal parts. It is okay. These lines parallel to AC, they indicates the composition of A component. The lines parallel to BC, they indicates the composition of C component, and the lines parallel to here AB, they indicates the composition of B component. And with the help of this, we can study the uh, three component system. Then many types of three component systems are possible, but uh, we will discuss only the acetic acid, chloroform and water system. Here at this B point there is a one phase. Then in this triangle there are two phases. There are two phases. This point it is a pilot point. This point it is called as a pilot point, and these are the tie lines here. These are the A2 dash, A2 double dash, A3, and these lines are called as tie lines, and here this P point it is also called as the pilot point. It is also called as the pilot point. With the help of this equilateral triangle, you can study the three component system. Okay, the next explanation we will see later on. Here A represents the 100% of component A. B point it represents the 100% B, and C point represents the 100% C. Okay. Here, this is a R point. This R point represents the 50% of A here, 50% of A and 30% of B and 20% of C, because in this triangle we can have the composition of all three components. We can express the composition of all three components. At this R point we have 50% A, 30% of B and 20% of C. Then where is C point? Oh, it is not same. Okay. So we will see later on in detail.